I'm so glad to be here. I'm privileged to be here. And I'm humbled to talk about cryo-PVI in front of such a knowledgeable auditorium full of experienced electrophysiologists. And actually, I think I saw my mentor, I see my proctor 6 years ago. He taught me how to do cryo-PVI. Thank you, Csaba. So today, we are talking about new cryoablation platform. So when I show you the slide with the 4 awfully familiar components of the platform, I think we could start and finish right here and saying, there you go. You have it. It's all familiar to you. Take it out to your lab, use it, and say what you think. But to intrigue you to do so, I will try to go over the short description of each component and try to support the premises about its efficacy and safety with the data where we have it, or maybe only with the pictures. Sometimes they tell more than 1,000 words. But first off, why another platform? We are not interested in marketing. We're not interested in industry, business. We are physicians. What's wrong with the current platform? Nothing's wrong. It's a good one. Remember, with current platform, we learned that how safe, reproducible, and effective is PVI. And you saw data yesterday during the debate. You saw Professor Gupta also had shared some data how effective, safe, and reproducible is cryo-PVI. And we learned that with the currently available platform. So why new? Why a new one? What's wrong with a new one? So what's good with a new one, sorry? So the design goal of the new line was to retain these aspects. It has to be safe, it has to be reproducible, effective. But the design goal also was to overcome some of the difficulties in the intra-procedural workflow that are repeatedly noted with operators. For years, operators were annoyed with some aspects. I'm talking about fighting to cross the groin or cross the septum. I'm talking about, ability to reliably stay there when you occlude the vein, especially in the right inferior. I'm talking about being annoyed that sometimes because of the design of the current platform, the catheter pops back in the atrium. And finally, as electrophysiologists, we don't like being out of control. If we cannot record the electrogram, we are out of control. We are delivering power, energy, and knowing hell what's happening. We don't know that. We don't like that. So there are obviously a couple of points where improvement might occur. So remember, when seeing it, the gross aspect of the polar X is just the same as a CB2. The whole distal hemisphere is cooled with injection coil. The thermocouple is the same place. It's a double air balloon with an inner lumen for the wire, or for the mapping wire, we call it here polar map. And the design and the goal was not to create a monster, not to create a cryo monster. It had to be just as powerful as CB2. So the bench test in a tissue mimicking phantoms had shown that it's equivalent, power-wise. Okay, so it's no wonder that the acute or chronic left atrial voltage maps after polar X ablation look alike those that you are used to see in the recent publications with the CB2 and a generation that came later, isn't it? Okay, so now this is introduction. Now let me tell you, what do we have to tell you about efficacy, safety, what's the data behind polar X so far? I will present the data from the Cmark study. Cmark study was non-randomized, single arm. Actually, it was feasibility in its nature study. It was like a multi-center study. And inclusion or exclusion criteria are fairly common for any other study that we cited today. It was paroxysmal AF population coming for the first PVI procedure. The endpoints were acute results, acute safety and efficacy. We're interested in acute results. Can we isolate the vein? and can we do it safely? Very important. So we tracked safety, efficacy, we tracked device-related and clinical adverse events. And the procedure were performed in 2 centers, my own in Split, Croatia, and Auckland, New Zealand. All the ablations in this study were done with a long tip catheter, 12 millimeter tip, 28 millimeter balloon. And we grade the occlusion, and we had very simple dosing protocol, very simple. If we observed TTI, time to isolation, within the first minute, we apply 3-minute freeze. Otherwise, we apply 4-minute freeze, no bonus freezes. So very simple dosing protocol. Yes, because this console allows you to track some of these, features that could warn you about, potential complications. We use so-called DMS, diaphragm motion sensor. We'll talk about that later on the workshop. And we track the esophageal temperature, probably both being something that you don't use in your current practice, but probably with this console and this platform, you might think of using it. And if esophageal temperature went down to 25, we abort mission. That's it. And then we remapped, 30 minutes post last application, we remapped the veins. And this is the summary of the results. We'll talk about that going through the components, but let me tell you, all the veins targeted were isolated using cryoballoon alone, so no need for touch-up. And let me tell you, even if it was very early experience, first 30 patients ever treated with the platform, every third procedure has to be described like a perfect cryo case. Single shot for each vein, bang. 4 applications, 4 veins, out of protocol, projected out of protocol duration of the procedure, 38, 42 minutes. Something that you are used to see in your practice when everything goes well. So even with the first 30 patients, there is a nice hunch of reproducibility. Okay, now let's go. Let me walk you through the components. And I will try to give you data or share my feelings for every component of the system. Let's try and see what console looks like. It's a small one with a smaller footprint and with a larger gas tank. Good. The interface is divided into 4 quadrants. The one is very familiar to you, giving you duration of cryo application and the temperature, and the graph. The second is important, and just below the main thing, just below are safety alert notifications, namely tracking 2 most important complications, esophageal injury and phrenic nerve injury. So there you can track esophageal temperature, and then you can track, during a right-sided ablation, you can track what happens with the phrenic nerve. The third quadrant gives you an overview of the important lesion parameters. I'm talking about the nadir temperature you reached. I'm talking about time needed to get to -40. I'm talking about time to isolation. I'm talking about towing time to 0. All these 4 are strongly associated with a durable PVI. We're going to talk to you later. The 4th quadrant is important for your technician. It serves for annotating the ablation sites and later on for data management. And we'll talk about in a workshop how can you manage the data and extract the data easily and store to patient records. So, the second and the most favorite improvement here, for me, it's a sheet. The polar sheet is a steerable sheet with 2 design changes that I think make a clear advantage. First is this taper tip. It allows smooth transition. It allows smooth crossing profile through the groin and through the septum. The second thing with this polar sheet, because of the more distal deflection point, you have tire bend radius. And this might ease an access to the right inferior, especially, cannulating and staying there also. And now I will show you a panel, I will show you a movie with 6 different panels. These are 6 consecutive patients. We performed it a year ago exactly, 6 consecutive patients. And you see transseptal crossing in all those 6. We line it up for the most smoothest to the hardest push ever. So the last panel we have to do, it's the hardest push ever we needed to cross in a 64 patients done so far. When you have a crossing profile like the last one with a current platform, you call that an easy approach. And this was the hardest ever we had to apply. So this was a clear advantage in very experience for us. Another set of data I'm showing here, and some of you might ask, why are you talking about sheet and showing out data that 3 out of 4 veins only needed a single ablation? Again, this is very early experience. And then, why are you showing us data about occlusion rate with a sheet? Because I think that it has to do something with the quality of the sheet. And you know, with this assembly, it was fairly easy, no matter the takeoff angle of the right inferior is. For us, it was fairly easy to seal the leaks and to get a good grade 4 occlusion. And look, across the veins, the high grade of grade 4 occlusion obtainable prior to ablation was achieved across all veins. It didn't matter is it right inferior or left superior. Reproducibility, very important thing. We come to the balloon. I said, gross aspect is the same, but one important difference. It uses modern thermoplastic materials that in turn offer that this balloon stays with a uniform size and pressure during the ablation. That's why you might forget and you might not see those micro dislodgements or even big popping back in the atrium. Apart from that, it's a cryo balloon. We used it in all maneuvers that are described with the current platform. It's just another cryo balloon. Have it there and use it. You see here all familiar maneuvers from pull down, from full looping, whatever. Another trick, talking about reproducibility. Consistent time to -40 across all 4 veins, and consistently within first minute, and with a mean nadir temperature of -53, and big -50 across all veins. Somewhat colder what you are used to see with the Medtronic, but don't be fooled with data. It's just a temperature data. You have to see it for yourself. What does that mean in your practice? Another important physical parameter, which is a very objective one, and for which we have a good data in the current publications, showing that towing time to zero of more than 10 seconds is a good predictor of a good freeze. The longer the towing time, I mean, the bigger the crystals, the bigger the ice crystals in a cell is formed, the longer the towing time. The longer the towing time, therefore, the greater the damage to the tissue. So towing time after 14.3 seconds, towing time to zero, 40.3 seconds, is something that we believe also testifies that this might be an effective platform. And now, finally, the last component, the polar map. Again, see it from the outside, the gross aspect, it's just another circular mapping catheter. It's a 20mm circular mapping catheter, but with one important difference. It's additional insulation layer that gives you ability to go up it again and record clear PV electrograms. Now, whenever we see in a medicine 0% or 100%, it's euphoric. And I hate to be euphoric. We are interventional physicians. There's no place for euphoria in interventional medicine. Here, you have euphoric number of 100% of PV electrograms visualized during cryo application when cryo was performed in sinus rhythm. I know, seeing is believing, so let me walk you through 2 movies. I want you to see and then believe. So, here's a typical example of the left superior ablation. Good grade 4 occlusion, and you cryo 5-6, we start with cryo application. Please track the cryo 5-6. Everybody sees that there is a PV potential, sharp, local field potential. Look how far is the polar map. It is at least 2 centimeters inside the vein. And yes, it's clear. We see clearly, but now look at cryo 3-4. How many of you were aware of this signal at cryo 3-4 at the beginning? Not too much, but clearly on 5-6, clearly PV. Okay, now we have a delay. We are down to minus 40 by 33 seconds. And we proceed. We see a delay, and isolation, eventually, right now. What you will tell me, because I cannot fool you, you're experienced electrophysiologist. Okay, guys, you were lucky. You just had a patient with a long PV sleeve. So no wonder you could record electrogram 2 centimeters inside the vein. But then I show you the next movie. So this is the right inferior. This is the right inferior. Look, yes, I have to do some pull down. Now I have good occlusion. I will ask my assistant to pull back the polar map to the most proximal position so I'm able to record a signal. So I start ablation and look cryo 1-2. Do you see any of the PV potentials? Please look at cryo 1-2. Just track it. We start ablation, we start pacing. Do you see any PV potentials? I didn't believe. Okay, but let's see what happens when we come down below 0. Okay, so now I take a look at cryo 1-2. There seems to be the second component separating. You see, it's very smallish, roundish, far-fieldish, but it's there. It's there. I see the second component. Okay, and we go, and then I try to see, is there a second component? Wait, still there? Right now, I don't see it anymore. I call isolation, and you will see annotation on the mark. You will see the green dot. I see isolation. And this is not patient-specific. This is not patient-specific. This is short-tip catheter with pulling polar map to the most proximal position. And still, just a far-fieldish signal, but it was there. We could track it, and we could apply our dosing strategy. To conclude, I hope you enjoyed this walkthrough to the system. I hope you enjoyed this walkthrough to the components. And you can choose for yourself. You can choose for yourself which set of details shown today will make you go and try use the system. From my perspective, it's a small, multiple advantages. Nothing crucial. It's just another crowd platform, but a small, multiple improvements that will keep you more reproducible, keep you on a safe side, and will keep you satisfied with something that you can offer to your patients. So I will, again, warn you about EP Connect. It's a platform recently launched, and I will post as soon as a Polar X get a Cmark. We'll post interesting cases from our database, and connect, interact, and let's exchange our ideas. And with that, I say goodbye to everyone. This is my young team and my small team in a split, in a sunny split, and we enjoy working. Thank you.